In this video, we'll go over multi-threading in Java. So we'll look at the concept of thread and how threads are created using the Java APIs. So basically, thread is a process that's basically created to execute certain statements for a program, for a given program. Typically on a computer, we have the CPU, which handles all of the threads. If there are multiple CPUs, multiple processors, then it becomes easier because then the threads can get assigned to each of those processors. But then when there's only one CPU, that's when the threads have to take turns, and the operating system basically decides what that scheme would be, if it would be a round robin fashion, or if there's some kind of priorities for the threads based on which the CPU time for each of them is decided. So if it is if there are multiple CPUs, then here's how the threads are organized. As you see in the first part of this slide, each of the threads can get assigned to each of the processors, and they're processed. But then when there is a single CPU, that's when the threads are shared by that single CPU. So in this case, you see that the first thread is processed for a little bit. So each thread is getting a little bit of the CPU time. So once the thread 1 time is up, then thread 2 gets its turn. Now it doesn't matter if the processing of the first thread was complete or not, it is put on hold. And then the second thread is processed. Once its time is up, the third thread is processed, and then we go back to the first thread, and then the second, and so on. So basically there is a certain time that's provided to each thread, and how much ever processing can be done within that time is done, and then the CPU moves on to the next thread and the next thread and so on. So that's the basic concept of threads. Now coming to Java specifically, and how we can implement threads in Java. The purpose for it would be, say there are some tasks that can happen in parallel. If the computation is independent, and if the computation can be divided up between two threads and have them do their processing, that's when it's useful to do this. So the way it works is, there is a certain task that we want to delegate to the thread. So we need to create a task object that basically encapsulates all of the processing that needs to be done, the statements that need to be executed. So so in Java, there is an interface called runnable, and the only method in it is the run method, and whatever is specified in the run method are the statements that get executed when the thread gets the CPU time. So whenever we want to create a thread, our first step would be to create a task class, and this task class should basically implement the runnable interface. What that means is it should provide the implementation of the run method, and that's what you see here. So we're creating a task class. Now this task class, we can call it whatever we want to. Basically its purpose is to specify the tasks for the thread. So this here you see task class implements runnable interface. Then we have the constructor. The main thing here is the implementation of this run method. This is where we need to tell the system what needs to be executed when this custom thread is executed. And then once the task class has been created, so here's our client class where we're going to create a new thread for some purpose. So we first create the task object, which is an instance of the task class, and then we create a new thread. So there's the thread class is available in Java API. So we create a new thread object, and to its constructor we have to pass the task object. So that's what you see over here. We're passing the task object. So now the thread is created and it's ready. We start the thread by invoking thread.start method. So that's when the thread begins its execution. And then this program can continue to do other things. There could be other statements or methods to be executed, but this thread, so some part of the work has been delegated to the thread, and it can independently, parallelly process all of those instructions. So that's the basic idea. We'll look at a simple example. In this example, what we want to do is create and run 3 threads. Now the purpose of these threads, the first thread, we wanted to print the letter A 100 times. The purpose of the second thread, we wanted to print the letter B 100 times. And then there's a third thread, and we want it to print integers 1 through 100. So basically we're creating these 3 threads because all of them are given their task, and then they can independently execute and process those instructions. So let's look at this example. It's task thread demo, and it will be available in the samples folder. So here's the code. As you can see in the main method, what we're doing is our first step is to create task objects. Then once the task objects are ready, then we create the thread objects and pass the task objects to the constructor, and then we start the 3 threads. Now, like I said, before we create the task objects, we need task classes. So whatever the task for each of these threads is. Now one of the tasks was printing character. So we wanted thread 1 to print the character A and thread 2 to print the character B. So what we're going to do is create a task class called printChar. It implements the interface runnable. So in here we'll have, there's 2 data fields. There's the character to be printed, we're going to store that, and the number of times we want it printed. And the reason we're creating it this way is so that this task class can be reused for multiple purposes. So the run method will basically, so in the constructor of this class, we are taking in a character and the number of times it needs to be printed. So that's the 2 arguments that are passed to the constructor, and then we're setting the data fields based on those values passed. Now, so like I said, because this class implements runnable, we have to provide the implementation for run method. So in the run method, we're providing instructions for it to print the character a fixed number of times, and that number is already specified in its data field through it was set in the constructor. So you see this for loop that basically goes from 0 to times, which is the number of times the character is to be printed, and then we have the print statement to print out the character. And then similarly, we're creating another task class to print numbers. This one also implements runnable. It stores the last number to be printed, that's its data field. So in the constructor, the last number to be printed is taken in as a parameter, and it's set to the data field last num. In the run method, we have instructions for it to print the numbers from 1 through the last number that was set. So those are our 2 task classes. So basically we're going to use them and create our task objects. Print A is the first task object. It's basically it's an instance of printChar class, and to the constructor we're passing the alphabet A, and we want it printed 100 times. Similarly, we're creating another task object called print B. In this case, we're passing the letter B, and we want it printed 100 times. And then we're creating a third task object called print 100. The purpose of this is to print numbers from 1 through 100. So we're using the print num task class for it, and we're passing the last number to be 100. Then now once our task objects are ready, we're going to create our threads. We're creating 3 threads, thread 1, thread 2, thread 3, and to them we're passing these corresponding task objects that were just created. And then we're starting our threads using the .start method. So basically what this program should do is, there are 3 threads and their tasks have been specified to the threads. So they will parallelly process the instructions as and when they get the CPU time. So depending on the processor, what you might see is when you execute this program, you most likely you should see a few A's printed, followed by a few B's, followed by a few numbers, again followed by a few A's, B's, and then the numbers and so on. But then this might vary depending on the processor and how fast it is and how many other processes are running on it already. So let's take a look at how the output looks on this computer. So I have already compiled the program, and as you can see, 3 class files got generated. One is the main class itself, task thread demo, and then in addition to that you see the 2 task classes as well, which were all written in one file. Okay, so I just executed this program, and you see that on this computer, basically all of the A's got printed. Well, maybe not. So some A's got printed followed by B's, and then A's got printed again for some reason. The third thread didn't get its turn, and then followed by B's, and then all of the numbers got printed. So again, like I said, it depends on the processor and its scheme of how it's allocating time for each of the threads, and you might see a variation depending on where you execute it. So a little bit about the thread class. So the Java API provides this class. It also implements the interface runnable, and then it has a number of useful properties. So we already saw the constructor. There's a default constructor, but then the constructor that we used was the one that takes in a task object as its input. Then we use the start method to start the thread. In addition to that, there are properties like is alive to check if the thread is currently running at any point of time in the program. We can invoke this method to see if it is still running. There's a set priority. We can set the priorities of the threads, and I'll talk a little bit about it. I'll talk about it in a little bit. There's join method. So the purpose of join is when you want a thread to wait for another thread to finish and bring its results. So I'll show an example of that as well. There's sleep. And the input to sleep is in milliseconds. So basically you can specify in milliseconds for how long you want the thread to basically to sleep, and what that means is it's basically not going to do its task during that period of time, which means if it gets processor time during that duration, then the turn is automatically passed on to the next thread. Then there is yield. Basically yield causes the thread to temporarily pause and allow other threads to execute. So basically it's giving its turn away. And then there's interrupt, if you want to interrupt the thread for any reason. So these are some of the useful properties that are there on the thread class. Now about the yield method, so it basically temporarily releases time for other threads, and the way to use it is, so in the task object where we have the run method and we're specifying the instructions, we can introduce the yield, we can invoke the yield method. Now yield method is static, so what that means is we don't need an instance of the class in order to invoke it. You can just say thread.yield. So and that's what you see over here. So what that would mean is this task object, whichever thread it's associated with, it's basically applying to that particular thread automatically. So in this case, what we're doing is after every number, we're basically printing numbers from 1 through the last number, say 100. After every number is printed, it's yielding, the thread is yielding its turn to the other threads in the system. So and it's doing that after every number that's printed. It gives up its turn once. So so that's what it means. Now, so similarly, the sleep method, it's also a static method. So we can directly just say thread dot sleep, and we can have the thread to sleep for a specified amount of time, and the time is specified in milliseconds. So here what we're doing is, once the first 50 numbers are printed, so when I is greater than or equal to 50, that's when we put the thread to sleep for 1 millisecond, and then it's back up again and waiting for its time with the processor. So that's the sleep method. Now the join method, like I said, the purpose of the join method is to stop and wait for another thread to finish and join. So the way it works is, in this example, what we want to do is, so there's a thread called thread 4, and the purpose is to print the character C 40 times, and we have started the thread. And then so this is, so the thread 4 is now independently tasked with printing the character C 40 times, and then we already have print 100, which is printing the numbers from 1 through last num. But then once it reaches 50, we want it to stop and then wait for thread 4 to join. So after the first 50 numbers are printed, we are going to basically wait for all of the C's to get printed, and then once that thread is done, completely done, its task, that's when this current thread will resume its operation. So that's what you see in this figure here. Here's our print 100 thread. It prints up to 50, and then it stops and waits for this other thread to finish and join. It is useful in some instances where, say, we want some other computation to be completed, and we need those results before, say, the current thread needs those results before it can continue processing. So that's when it can basically issue the join command and wait at that point for the other thread to complete and then continue. So that's the join method. In addition to this, there's isAlive, interrupt, and isInterrupted. So basically, isAlive and isInterrupted will basically check if the thread is still running or not, and it returns a true if the thread is either in a ready, blocked, or running state, and it will return false if the thread is finished or if it was stopped for some reason. Interrupt, on the other hand, will it basically checks if the interrupted flag has been set on the thread, and if it is, then it will return a true, else it returns a false. And so that's the isInterrupt method. And then interrupt method basically is a way to, if there is a ready, if there's a thread in a ready state or in a running state, the interrupt method will set the interrupted flag to true, which means the thread will then get blocked and wait till that flag is released. So basically it's like a toggle. It's a way to set that flag to true or false depending on which state it is in currently. It toggles that state. There are also a few deprecated methods that are not used anymore. Stop, suspend, and resume are those methods. Instead, the best way to stop a thread or suspend a thread is basically to just set the thread variable to null. So assign a null to the thread variable, and that will indicate that we want it to stop or suspend. Thread priority is another property that we saw earlier when we looked at the thread class API. So basically, priorities can be set when nothing is specified. It's default priority, which is just the normal priority. So there are a set of constants that are used for this priority. There's a min, max, and norm or normal priority. So we can set the value to any of these. The value that it takes in is an integer, and the integer values go from 1 through 10, and they set the values to either a min, max, or somewhere in between. So the integer value of the priority can be set. Thread synchronization is also very important. When the threads are acting independently with no shared resources, then there's no issues. They independently do their job. There's thread synchronization issues whenever there's a shared resource. and then the shared resource needs to be locked by a thread before it starts using it, to ensure that it doesn't get corrupted, or incorrect computation is not done by other threads. So it's very important to use the lock and unlock feature of the thread of shared resources in order to not get into thread synchronization problems. So to give you an example, say if it's a banking application and say there are two threads concurrently doing some operations, and say they both are accessing accounts and account balances, so which means that the balance variable is a shared resource that both threads are accessing. So what could happen is, say in the first step, initially the balance in the account, and say both are operating on the same account, say the balance in the account was 0, then bank.getBalance will basically fetch that 0, add 1 to it, and store that as the new balance. As soon as this instruction is completed, say the CPU time is switched to the second thread, then in the second thread it's again going to get the balance, which is 0 currently, and add 1 to it, and a new balance with the second thread is now 1. And then again, the thread, the CPU time, say the first thread gets the CPU time, and it sets the balance value based on whatever it computed. So we have our new balance is 1, and then say the CPU gets to the second thread again, and say it tries to set the new balance again, then this could result in corrupting the balance information of the account. So it's very important to in these cases to lock that shared resource to ensure that it's not corrupted. So these are some of the considerations to be looked at when you're doing programming with threads. That's all I have in this video. Thank you.